So today I will talk about vector product or cross product. Earlier I talked about dot product, right? So cross product, as we know that torque, this can also be expressed in the form of a vector product, or area can also be area of a parallelogram. It can also be expressed in the form of a what do we call a cross product. So generally the cross product any two vectors is generally denoted by a cross b. It's like this: a is a vector and b is another vector, and then their cross product is represented by a cross b. And let us define it. That how do we define it? So the cross product of two vectors a and b is defined as a vector c. Let us call it as a vector c whose magnitude is equal to the product of magnitude of two vectors multiplied by the sine of the angle between them and is directed along a unit vector n cap, which is perpendicular to the plane containing A and B. So this is a very simple definition of A cross B. So therefore mathematically A cross B is another vector. Let us call that as C vector, and it is equal to magnitude of both the vectors and sine of the angle between them, and it is directed normal to the plane containing both A and B. So this is the mathematical definition of A cross B. Let us try to understand it diagrammatically. So to understand it diagrammatically, let us consider a plane. There is a plane. Consider there is a plane. Say this is a plane, and let us call there is a one vector A and there is another vector B in this plane, and both are making an angle theta. Then a vector which is perpendicular to these two vectors is known as A cross B, such that it's equal to A B sine of theta, and this direction is n cap. So n cap is this direction. It's a normal to this, right? It's a normal to this plane, right? So it is xy plane. If A and B vector lying in the xy plane, means what does it mean? That means if A and B, these two vectors, these are in the xy plane, then A cross B is always along z-axis, right? So this is all about it. And let us understand it with the help of some other example. Say I am having a screw. Say this is a screw, and say this screw is rotated, say it is A and it is B, it is rotated along B. Then this screw advances in this direction, then this direction is n cap, and the vector along which it moves, because it's rotated in this way, then this is known as A cross B. This is a very simple example, right? So, and if I rotate B towards A, then this will move towards like this, means in the opposite direction. That means if I rotate in opposite, means if I write down B cross A, then again the magnitude will again remain the same, because A, B both are identical. Whether I will talk about B A or I will talk about AB, both are same. But what will happen when the screw is rotated in the opposite direction? It advances in the opposite way, right? So that means it is sine of theta, but the direction will be minus n cap. It is opposite to it. So what we are concluding out of it? We are concluding that A cross B is equal to minus B cross A, right? Means from this, because A cross B is what? A cross B is this one. So if I compare these two equations 1 and 2, then what I am concluding? I am concluding this. That means vector product is not commutative. Vector product is not commutative, right? So this is all about the vector product or the cross product. Now let us talk about the cross product and unit vectors. Cross product and unit vectors. Let me talk about cross product and unit vectors. Cross product and unit vectors. So let us consider a coordinate system. Say it is I, x-axis, say this is I cap, this is j cap, and this is k cap. So if I talk about I cross j, then it's always will be k cap, and if I rotate j to k, then it's again I cap. J cross I, then it's always, sorry, j cross k, then it's always I cap. And if we talk about, means j cross k gives us I cap, and k cross I gives us minus, sorry, not minus but the j cap, right? That's what we are getting here. And if I try to look at this, their order is counterclockwise. So, but if I rotate j to I, means if I talk about j cross I, so here it is I, it is j, and it is k. So if I rotate j to I, then again I am getting k, but it is opposite to it, because its rotation is opposite to it. So that means I am not getting k, but it is minus k. And similarly, if we talk about k cross j, then I am getting minus I. And similarly, if I talk about I cross k, then I am getting minus j. So here it is the clockwise. Here it is a clockwise order. it's a clockwise order, right? So these are the results which I'm getting for the unit vectors. So we have to keep these results in mind. And here the angle between these two will be 90 degree. I cross j, j cross k, and the k cross I. Means the angle between I and j will be 90, or the pi by 2, and j and k, it's again pi by 2, and k and I, it will be again be pi by 2. Then let us talk about I cross I. So the magnitude of this vector is 1 into sine of 0 degree, because the angle between I and I will be 0. So sine 0 and unit vector, let us say it is n cap. Sine 0 is 0. So it makes it as 0 vector. It makes it 0 vector, not 0, but it's a 0 vector. Similarly, we can say that j cross j is 0 vector and k cross k is also 0 vector. Now let me express cross product in terms of Cartesian coordinates. Now let us express cross product in terms of Cartesian coordinates. Cross product in terms of Cartesian coordinates. So let us call this A is equal to axi cap, ayj cap, and azk cap. Similarly, let me write down that this B vector is equal to bxi cap, by j cap, and bzk cap, and let us try to find out their cross product. So this A cross B, it can be written like this: axi cap, ayj cap, azk cap, cross bxi cap, byj cap, and vzk cap, right? So this is the, let me try to simplify it. So it is axi cap cross bxi cap plus byj cap plus bzk cap plus ayj cap cross bxi cap, byj cap, bzk cap, and azk cap cross bxi cap, byj cap, and vzk cap. So this is equal to, here I multiplied with it, so it is ax bxi cross I plus ax by, it is I cross j, plus ax bz I cross k, plus this a by bx, it is j cross I, it is j cross I plus a by b by j cross j plus a by bz, it is j cross k. Now here it is plus az bx, it's k cross I plus az b by it is k cross j plus az bz, it is k cross k. So let me recall few results. Say I cross I, it will be 0, j cross j, it also be 0, and k cross k, it's also 0. and I cross j, as I have written, I cross j is equal to, let me, I cross j is basically k cap, and j cross I, it is minus k cap, and it is I cross k, it's I cross k is minus j cap, and k cross I is j, and similarly j cross k is I, and k cross j is minus I, right? So if I put all these values, then this A cross B, it will become is equal to, so it's a k cap, it's also k cap, so let us put these together. So it is ax by, and here it's minus, so it makes it minus a by bx, it's k cap. Now let us talk about it. It is a by bz, it's because this is 0, this is 0 also, so a by plus a by bz, a by bz, a by bz, and here it is azby with negative sign, and I will be here, and then minus j will be here, so let us take it like this. So minus j, it is axvz, right? And yeah, here it is minus again, so az bx, it will remain as it is. So I have arranged it in this way. So let me rearrange it again. So if I rearrange it, it can be written as, first of all let me talk about I and then j and then k. So it is a y vz minus az vy, it's I cap, minus j ax vy, ax bz minus az bx, plus k ax vy minus ay bx, and let me rearrange it again. Now it can be written as, means a cross b, it is equal to, say I cap can be written like this. Let me write down, it is ay az by bz. It can be written like this because it's this multiplied by this is our first term, and then it is multiplied with this, it is the second term, and taking the negative of these two. This is a way to look at it. It's a simple properties of determinants. And then minus j, it's again ax az bx bz plus k, it is ax ay and bx by. So it's a simplest way, it's a simple expansion of it, third order determinant, whose first row will be I minus I, j and k, means it is I, j, it's k, it's ax ay az bx by and bz, right? So thus in nutshell I can say that this a cross b, it can be written as like this: I cap, j cap and k cap. It is ax ay az bx by bz. So if two vectors are given in the form of Cartesian form, then we can write down the determinant, the cross product in the form of a 3 by 3 order determinant. So that's all for today's lecture. So this is the first part of cross product. In the second lecture I will talk about few other properties of and some problems based on cross product. So that's all for this.